Hello, everybody. Thank you for having a time and intention to join our today's webinar. I appreciate you dedicated 1 hour to hear about GoodVision live traffic deployment. While we are waiting for maybe some more participants to join, I will briefly explain how our session will look like today. We divided the webinar onto 4 quarters. The first quarter is about components of the live traffic, hardware components, what to prepare, how to link them, and how to have the hardware prepared for live video processing. The second quarter is about the platform. So I will be sharing my screen and showing you how to set up the processing in GoodVision Video Insights environment. The third quarter of the webinar is dedicated to various outputs. So what you can expect from the processing, what kind of data will you get? And the last but not least is use cases. It's maybe even most important for users, how platform can be utilized to fit into your specific projects, to fit your specific needs. And then we opened the chat. You can post your questions into a chat whenever you want. Please don't hold yourself. If you have something popping up in your mind and you want to ask, just post it in chat. Depending on activity, I will either do pauses between chapters, or I will answer all the questions at the end of the session. We do not expect the session to take longer than 1 hour. So let's start. Live traffic. For those of you who are not familiar with GoodVision Video Insights at all, GoodVision Video Insights is a platform that extracts data about objects from the video footage, logs it, builds trajectories, and allows you to do a variety of analysis and get reports, get some data. And live traffic is an extension that gives you possibility to have data in a live mode. You don't need to record the video and then upload it to cloud and then have it processed. You take a live stream, live feed from your camera and have the data extracted in air immediately. So components, what is required to have a system being prepared for processing data? First, of course, it's camera. There is a minimal requirement to camera. Basically, it's 720p resolution of the camera. It doesn't mean that lower resolution will not be processed, but it means that detection will not be that accurate. There is a minimal of 15 frames per second rate. Otherwise, engine might think that camera is disconnected. And obviously, it will be very hard for the AI to trace the objects, especially those on the highway that moving with a high speed if the frame rate is lower. Codecs that we support are H265 and H264. And at the moment, we support RTSP protocol, which is pretty generic for IP cameras, but also HLS, which stands for HTTP live streaming protocol. We encourage you to use RTSP protocol, but yeah, we added HLS to have to give you more flexibility. The heart of the processing, the heart of the live traffic is the processing unit. We support a variety of units. Just to not overload you with multiple options. We narrowed our main offering to 2 units that differ by computing power. The entry-level unit, which is Ladder 130B, can process from 1 to 4 streams, depending on stream quality and data to be extracted. And Ladder 2290 unit, it hosts powerful NVIDIA GPU, the server deployment GPU. And this unit can process much more streams, up to 16, maybe even more. Again, it will really depend on your project, on what data do you need to be extracted, and what additional software modules do you want to deploy on top of live traffic. And third part is the GoodVision Video Insights that is hosted in a cloud. So system has 3 components: camera, processing unit, and cloud, the platform that is hosted on a server. The main challenge is to link these 3 components together. And you can imagine the biggest challenge is linking camera to processing unit, because this channel requires a really wide broadband. Video requires wide broadband to be transferred to computing unit. And well, I've listed several options that we think are preferable for this communication channel in between camera and processing unit, which is local area network, fiber optics, or 5G. But actually, the deployment architecture will depend on your needs, on your tasks. Do you have an existing infrastructure of cameras or not? If you do have infrastructure of cameras, then probably there is already a network, and you have maybe a data center where you will host the unit. So this part is not that important for you. If you don't have infrastructure of cameras and you're just planning to deploy them, then you have to make very conscious choice about what type of connection will you need. Will you want to place the edge unit, the processing unit, on site along with the camera? Because in this case, as we don't need a really speedy internet connection in between processing unit and cloud, you can save on connecting the processing unit to cloud by putting the 4G modem, for example, or using a Wi-Fi if possible. My experience is telling me that the hardest part of preparing the hardware for the live traffic is linking all the components. And this process generates a lot of issues and errors. We will assist you with it, with preparing your network, preparing the hardware setup, but biggest part of the preparation comes on you. So once 3 components, which is camera, processing unit, and cloud, are linked together, we can set up the streaming. And comparing to time that is required to do the hardware setup, the software setup is flashy. I mean, we can do it within 2 or 3 minutes. I will show you right now how easy it is. I will switch to Video Insights environment. This is the GoodVision Video Insights platform. And once you have your license, the live traffic licenses assigned to your account, along with devices being configured. Oh, sorry, I forgot to mention. Important thing about the devices. You can get them either within GoodVision live traffic kit, depending on your project, we can send you the kit that contains processing unit and camera. The processing unit comes with live traffic already pre-installed, so the only thing you need is just to link them together, to link camera to processing unit and processing unit to internet. If, for example, you have a project with a number of devices, with dozens of devices, obviously there is no sense to send them through our office. We will link you to our partner, supplier, Lanner. Lanner has headquarters in multiple areas, and units will come prepared to host GoodVision live traffic, and our dev team will guide you through process of setting up the live traffic software, to deploying live traffic software to processing unit. It's really not something very complicated. Basically, we will ask you to connect the unit that you received from manufacturer to internet by plugging in the network cable, connect monitor, keyboard, and mouse. The computing unit has ports for it, and perform, as far as I remember, 3 or 4 commands in a terminal. It's that easy. After that, we will take it from there, and we will deploy remotely live traffic to your unit. So it doesn't take much time to configure the unit, even if you received it from the manufacturer, to prepare it for processing. Now getting back to GoodVision Video Insights environment. This is the section of your account where you will see your live traffic devices. These are 2 physical devices, 2 computing processing units that are assigned to my account. And now I will connect a video stream. I have a camera powered on, and I know the URL of the stream. So I will add the URL. In this case, it is RTSP protocol. You need to know the IP address of your stream and port for the streaming. And then there will be the second part. It will vary depending on your IP camera manufacturer. You name the stream, test stream for webinar. And you choose where this camera is situated. It is extremely important to set the correct location, because based on that, camera processing unit will understand what's the time, the local time for the events. Otherwise, if you will specify non-relevant location, you will have wrong timing for the events. My stream is here. And you can choose between traffic camera and ANPR camera. These 2, they vary based on their position and zoom. We do have ANPR, but for ANPR, the camera must be situated as low as possible to have a clear view of the license plate. So by default, we always use traffic video stream type. Once you click save, the device will try to connect to stream and to check if it's actually getting anything from there. If there's no stream by that address that you specified, you will get the error like not possible to connect to streams. Otherwise, if it was verified successfully, you will see this message ready to be processed. It differs from processing stopped. Here you see I have already 5 streams. 4 are processing stopped state. It means that I have already processed them and then stopped it for whatever reason. And ready to be processed means that stream is ready, but we never processed it. We didn't get any data from it. In order to start processing the stream, start to get data, we must tell the GoodVision video insights where to store the data. Otherwise, so once you edit a stream, system needs to know where do you want to store the data. So we will click Save. Our device and our streams are all set. We only need to go and create the project. Those of you who worked with cloud processing already familiar with this process. So we create the project. Let's name it Webinar Test Live. You choose the classification scheme you want to use. And then within this project, you will create a location. It will be Varna. And then you have to add the data source. Usually when you have a pre-recorded video and you want to process it, you add the GoodVision Vault, the storage. But in case of live traffic, if you have a camera feed, you add the live traffic unit as a data source for your project. Let's name it, it's test cam 1. Here, you have to select in between those units that you physically have assigned to your account. This is the one I connected the stream. And here you have a selection of stream. If stream was previously connected to another project, it will be faded out. And the stream that was never linked to any other project will be marked black. So we select this stream. We click Save. And that's it. We are set. We can start. There is an indication that processing stopped. We can start processing just right now. Start processing. The device will again try to connect the stream second time and verify if there's still the frames are coming. So maybe camera was powered off, because after you connected stream to your device and before you configure the project, hours or days can pass, right? So system wants to make sure there is a camera there. It tries to get some frames from the stream, and once it succeeds, the state of the data source will change to processing. Let's give it a couple minutes. Yeah, we went through the steps and we are about to start processing and set up the scene. Okay, it changed the state to processing. It means that unit started getting some data. Let's check. We have a possibility to check how detection happens in processing unit itself. There are some requirements. In order to see detection in a live mode, you must first use the desktop application. Just to access the GoodVision Video Insights environment, you can either use a browser or desktop application. Live detection will not work in a browser. You have to download and install the desktop app. And second, your host that you are using to access the video insights should be in a same network segment with the processing unit. These limitations are because of privacy reasons. We are not broadcasting the live stream out of your network. The only data that goes out of your network is data related to objects like trajectories. So once we press play button, we will see the live processing. This option here is just to make sure that detection happens. We do not recommend using this option on a permanent basis because it takes some computing resources from the processing unit. And obviously, you can process more streams at once if you don't use this, we call it live plotting or live detection option. In this case, the quality of camera is actually 720p. I don't think the position of this camera is very good. It's still okay. So it's like raised above the asphalt, maybe four meters or something. But I would place it higher if possible. I don't know why is it that low. So once we start processing, you can expect 3 outputs. With GoodVision Video Insights Cloud Processing, you have only one output, which is trajectories. You don't see trajectories yet because I have just connected the stream. But let me show you maybe some other streams that that I was processing previously. For example, this one, you see a lot of trajectories. This is the regular picture if you have uploaded and processed pre-recorded video file. But you will see the same trajectories with the live traffic. So we still detect all the object and we save their trajectories, and you can work with them like with the cloud processed video. So you can place lines, you can place draw zones, you can build filters, you can generate reports. It's really up to you how to utilize this possibility to work with the outputs. The trajectories are uploaded to cloud every 20 minutes. Do not load the internet connection. It's easier to send trajectories as a bundle for a time period. There's only one difference when you work with trajectory. The advantage of live traffic is that if you want to have a report for the day or for any other period, you can set it up as scheduled report. So here with the live traffic, you will have a recurring report. You can set it up to be sent to you or on a daily or weekly or monthly basis. For example, I want to have a report on a daily basis for a vehicle taking specific road for 24 hours period with the time unit. We're talking about TMC report for the time period of 1 hour, and you click save. You created the periodical TMC report. Every day you will receive an email with the Excel file, with a table with this TMC report. You don't have to go to Video Insights and generate it every day. If you have your live camera running, you will start receiving this TMC report based on your preferences. So that's the difference for the first output that we call historical data, because you get historical data with the live traffic for those periods that already being processed. The second output is what we call integration. You can have any event that is available within a platform to be reported to third-party API, to outer API. Imagine I want to have objects that cross this line in this direction being immediately reported and send the payload to outer URL. I would go to Analyze Data section, and here we have a set of integration types. So I choose what kind of report do I want to get. Is it the basic intrusion report that will inform me about every object that fulfilled the condition, or average occupancy, average speed, average headway, and how do I want to receive it? Immediately after this event happened, or periodically, every hour, day? It depends on your preferences. But let's say I want to have it instantly being reported to me. I select the filter that I previously created on the main screen, and if I want to include images or not, because we can include images in addition to data payload to messages that we send to external API. So here you will have to specify the URL of external API. Imagine I don't need this event to be sent to external API right now. I will show you how it looks like. And I click Save. And here you will see the counts. It means how many times this event was triggered. Right now it's 0, but once any object, in this case cross line 1 in direction from down to up, it will log this event and send the payload. Now 1, 2, it happens in real time. So actually there were 2, 3 already object crossed this line, 4, etc., etc. Let me show you how actually report looks like. This is how payload looks like. We send information about when this event happened, what triggered it, what type of object, was it a car or a bus, how was it detected, what was the name of this event, and this is the image that we can send and we're sending along with the payload. It's up to third-party API to interpret this information and show it in a certain within a certain interface. And that's it about second output. So first output is historical data, trajectories, and you work with them. You generate TMC report, vehicle risk report, any kind of reports, like with a cloud processing. The second is integration, when you send messages to third-party API, and messages can contain not only data but also images, snapshots of the scene or snapshots of the object that triggered this event. And we have a third option as output for the platform, and that will probably be the mainly utilized option. It's a live dashboard. Live dashboard is a hybrid of already processed data and real-time data that coming right now. Let me show you. Let's do the average speed measurement, for example. So I will draw 2 lines, maybe here and here. I will specify the distance between these 2 lines. Let's assume it's roughly 6 meters. And I will choose the way I want to see this widget. Do I want to see it as a bar graph or as a single value? Let's choose multiple option. I want to see it as a single value and be averaged for the last 60 minutes. Okay, maybe not last 60. Let's make it 15 minutes. And compared to previous period. Save. And I also want to see it as a bar graph to be averaged for the last 60 minutes, to be averaged with 5 minutes width of the bars, and to show last 60 minutes. Let's make it 3 hours. Okay, we click Save, and from now on, we start collecting data. As you see, there is nothing to show yet because we only created this widget. It's basically if you would place your subordinate on this intersection and tell him, listen, from now on, you have to log the speed of every vehicle that comes by. And he starts to log it. Let's give him some time and configure some more events. We have a violations widgets. For now, it's illegal vehicle stop. So if object stops somewhere where it's not allowed, we will talk later about use cases. If it breaks the speed limit, or wrong way driving, if it drives the wrong way. This one is one of the simplest. Here you will draw two lines. Obviously, this is the wrong way. Otherwise, you can change the direction. But here it's all set correct. So once you click next, you can have it as a table view. Table view differs from any other widget because it includes images for the violations. Start collecting data. And to show you images, let me add a simple one, directional cross detection, for example. Line 1, yes. And save. Start collecting data. So we see that there were already the measurement of the average speed. Obviously, there are vehicles, they move there. Let's check. Yeah, so vehicles are moving here. We can also check it by going to analyze data and see the counts for the line. Let's go back to live dashboard. It's updated. There is an indication of how often this widget is updated. There is a latency, but it's almost immediately. It takes usually no longer than 1 minute to update the information on the board. Let's create something with a snapshot of the scene. For example, we will create illegal vehicle stop widget. And here's the area where actually vehicles stop to give way for incoming vehicles. But we will draw this area just to check how the widget works. So you enter the time that you consider an illegal stop. So more than anything that stops for more than 1 second will be logged. And you choose the table view for the widget. Click Save, start collecting data. And let's give it a couple minutes, maybe. That's about 3 possible outputs for the live traffic. Let's again remind ourselves about them. First is trajectories, and you work with them as with historical data. Second is integration or external API. You can send data to outer API. The data is payload, the information about event that you specify, and the image, the snapshot of the scene or of the object that triggered the event. And third type is a live dashboard. That is the hybrid instrument to give you the understanding what's going on site right now. Wrong way driving, there will be no, let's delete this one because I know that location, nobody will drive in a wrong way there. But let's leave this one and have some count for average speed measurement. Again, next update, 16 cars. Yeah, so we created the segmented widget that shows us that 16 cars, the 16 objects crossed this specific line within last 60 minutes. So if you want to monitor the site for the traffic intensity, you will probably pick the 15 minutes or 5 minutes interval. If you want to monitor multiple sites on a daily basis, then probably intervals will be bigger. we will get back to this live dashboard section once we have some illegal vehicle stop detections. Yeah, so this is how normally the widget for intensive road segment would look like. And let's talk about use cases. We have a platform that has a variety of tools. And these tools might be used in variety of projects. The different combinations of tools make you use them for different purposes. However, we have some examples where we already did some either tests or we have ongoing projects, live projects, and we divided them onto 4 main, let's say, directions. So first, highways. For highways, we have the AIS system, Automated Incident Detection System, where the traffic is measured in multiple locations. Of course, it is required to have cameras installed, not in a single location. In a single location, we'll still be able to monitor it for traffic violations and incidents. But for automated incident detection, we need to have more outputs. Let's have more inputs. And we will report traffic congestion or congestions propagating or isolated congestions. Then level of service, basically monitoring the intensity of traffic based on different parameters like speed or number of vehicles, or we can measure the capacity or the utilization of specific road segment or lane in PCUs, in passenger car units. And traffic safety and violations monitoring, we basically detect vehicles that stopped in non-stop areas or that did illegal turn or U-turn or whatever, or discharged into a wrong lane. There is a list of traffic violations that we can detect. The second direction is intersections, or basically streets in the cities. Live traffic can be used for traffic control by integrating the live traffic into intersection traffic control, integrating it with traffic lights, for example. We had several projects where the intersection control system received the input from live traffic, like a number of vehicles in specific lane or specific incoming road, and turned the light from red to green to release the queue. And counting, of course, just to monitor the load on intersection and to be informed if the capacity of the intersection is already below the service demand and queue is building up. We have a solution for parking. Obviously, one of the very, obvious things, because we can monitor the zone for the stopped car or car that stopped there for a specific time. We can count the time of the object being in area, either stopped or moving, but still within the area. So we can monitor the occupancy of the parking area or lots. And we also have a number of solutions for tolling, for tolled roads. We call them off plaza, on plaza, and in plaza. Off plaza is we monitor the incoming road several kilometers to plaza, to toll gate, and we provide plaza crew with estimation on service demand, so they could either open additional gates or redirect the traffic or perform whatever means to avoid queue building up in front of the plaza. On Plaza solution, we can monitor the lanes just in front of Plaza for the number of vehicles occupying them, and let crew know about the occupancy ratio, to let crew know that some specific lanes are completely occupied. Maybe they can send information to variable signs and let driver know that gate number 5 is only 40% busy, so please move there, all those things. In Plaza, as we have ANPR engine, we can read the license plate number, and we can send it to, again, third-party system that would be responsible for invoicing drivers, or at least working with this data. We don't have a system that will cover the entire setup of tolling process. We only capture the license plate number and can send it to external API, but we are very good in ANPR comparing to existing services. And moreover, we can adapt the specific processing unit to local needs, which is we are very flexible on adapting to local specific images or visual appearance of objects. Let's go back to live dashboards, and I will show you how the captured images of those objects that we think did illegal stop. The resolution of camera is pretty low, but still, there was an object that stopped there at the zone that we draw, as it was probably giving weight for incoming from opposite direction traffic. So this is how this table view of the widget looks like. We capture images, and for whatever reason, we don't have average speed measurement bar graph. Oh, I've specified here time unit as 15 minutes, so it's too long. We're very fast. Let's make it 1 minute and last 60 minutes, and we should see the graph. Yeah. So there were not many cars, but this is the measured average speed for that specific monitored, let's say, trajectory that we created. The widgets that you build here in the live dashboard are not reflected on the main screen. This is the advantage of the live dashboard. Once you create a widget, you draw lines or draw areas, all those lines and areas are not reflected on mainstream, because otherwise you will have a mess. You can create as many widgets as you want here, but the region will still be visible. You will not be messing up with a lot of lines and areas. So every time you want to create new widget, directional cross detection, you will see a blank scene. You will not see those lines and area and zones that you placed previously. Thank you again for your participation, for 1 hour spent with GoodVision. Hope to see you next time. There will be more interesting webinars this year, and looking forward to see you again during next webinar. Bye-bye, everybody.